Okay, so in this video we're going to quickly generalize the triangle inequality. So the fourth axiom of a metric space was that the distance between any 2 points x and y was going to be less than or equal to the distance between x and a third point z plus the distance between that third point z and y. Okay, so that was called the triangle inequality because if we imagine in R2 with the usual notion of distance, and we have 2 points x and y, if we take any third point z, even if z is actually on the straight line connecting them, then the distance between x and z and the distance between z and y, in that case, if z is on that straight line, it's going to actually be equal to the distance between x and y, but this inequality therefore still holds. And obviously if z is over here somewhere, then it's going to be, this side is going to be strictly greater than this side. Okay, so if we want to generalize the triangle inequality, then we could take a finite number of points. So we could take x1, x2, x3, all the way up to some x, let's say m, so xm, and then what we could say is that the distance between x and y is less than or equal to the distance between x and x1 plus the distance between x1 and y. So we just apply the triangle inequality once. Then we could apply the triangle inequality to the distance between x1 and y and say that this is less than or equal to the distance between x1 and x2 plus the distance between x2 and y. So basically what we're doing is we started off by using the triangle inequality on dxy and we got this with the first point x1. So what we're doing is we have 2 points x and y, and then we have a bunch of points x1, let's say x2 over here, x3, x4, all the way up to some xm. And what we're saying basically is that if we go, what we're going to prove basically is that if we go through this path like that, the sum of all these distances is going to be greater than or equal to the distance between x and y. And this is, so basically the overall theorem is going to be that the distance between x and y is less than or equal to the distance between x and x1 plus the distance between x1 and x2 plus all the way up to plus the distance between xm and y is what we want to prove. That's the generalization of the triangle inequality, that if you take, if you take a finite number of points, then between points between x and y, then this inequality holds. And the way that you prove it is that you'd start off by saying that the distance between x and y is less than or equal to the distance between x and x1 plus the distance between x1 and y. Then you'd say that the distance between x1 and y is less than or equal to this. So what we can then do is apply, we can add this to both sides of this inequality and get the distance of x1, the distance between x, comma x1, plus the distance between x1 and y is less than or equal to the distance between x1. X again, that comma is going to get me. Distance between x and x1 plus the distance between x1 and x2 plus the distance between x2 and y. Okay, and then what we can do is we can apply the transitive property of inequalities and say that if this is less than or equal to this and this is less than or equal to this, then this overall shows that distance between xy is less than or equal to distance between x and x1 plus the distance between x1 and x2 plus the distance between x2 and y. So just to recap what I did there, I took this inequality here, I said add the distance between x and x1 to both sides of this inequality. Because it's an ordered field, because the real numbers are an ordered field, the inequality still holds if I add a number to both sides. And then I use the transitive property of the order to say that if this sum here is less than or equal to this sum, then and this is less than or equal to this, it implies that this is less than or equal to this. So what I've done there is I've extended the triangle inequality now to 2 points in between x and y, and then by induction what you can do is you can derive the next one. So if we were to do this by induction, we'd say, it's true for n is equal to 1 or whatever, and then we'd assume it was true for n is equal to k, prove it's true for n is equal to k plus 1, and it's pretty obvious that you're going to be able to prove that pretty easily. So If not, if you don't like proof by induction, then you could just continue this process on until you get up to the state, until you've got your m points. So basically this statement is going to be true, because next what I'd do is I'd say the distance between x2 and y is less than or equal to the distance between x2 and x3 plus the distance between x3 and y. And then what I'd do is I'd add this bit here onto both sides of that, so I'd get this whole thing on this side here, and I'd get something else on this side, and then I'd apply the transitive property to say that this is less than or equal to this plus this, and you would continue on like that until you had all m points.